Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, another 300B build, and while this is using the same schematic and all that kind of stuff on our other builds, it's going to be a different layout. And this time, the customer wanted to supply their own chassis, or at least the wood part. And he wanted to do his own thing and then send me this to finish it up. And so I had another viewer that has a CNC machine. We worked out the layout on this top and bottom plate, and then I got it black anodized, which I think looks really nice. And we're going with the silver trim and full ISO iron, the choke, the power transformer, everything. And I'm going to go over in the next couple of videos about how we're laying things out, some of the challenges of having this wood surround, because some of the stuff previously was bolted to the sides of the chassis and used as a heat sink, which we can't do with wood. And like, for example, we can't put the power switch, we didn't want to put the power switch through the wood. We wanted to leave it like really, plain on the front. So we'll get inside and show you the challenges of this layout and how I'm going to be laying all this stuff out. Okay, so we got some more of the amp wired up. When we left off, here was our B+. And so we've got some heavy, solid core copper wire coming over here to these two 50 ohm dropping resistors. And this is where the power supply turns into a split rail. We had a single rail up to this point, but then we have these two dropping resistors. We have these two 500 volt 100 UF caps that go from here to ground. We've got this fat ground lead that comes over here. It's kind of hard to see. Okay, maybe you can see now. We got this ground lead that comes around here. It goes underneath these caps, and then it's got a jumper here, nice fat jumper that ties these two together. So this is a remote ground point for this little area of the amplifier. So we got the DC off these two rectifiers. Comes over here. We got our two caps, one on the input, one on the output of the regulator. They come up here to the heater. Same thing over on this side. The DC comes over here to the 5 volt regulator. We have I believe it's a 10 UF on the input and a 22 UF tantalum caps on the output. And then we've got the heaters. And one of the things I do is I reverse the polarity on the heaters from one tube to the other, so that every couple of months you can swap the two output tubes and it reverses the polarity on the heater, which allows you to use up all of the tube. If you just have the DC running in one direction all of the time, one end of the filament sees more current than the other one, or more use. And so by rotating the tubes, you rotate the direction of the DC going through the tube. So on this tube, that's positive, that's negative. This one, that's positive, that's negative. These come over here to this tag strip here. We got two 50 ohm wire wound resistors, non-inductive, that create a virtual center tap for the cathode to be then grounded. And it's grounded through the cathode resistor that's mounted on the top of the amplifier, and it looks like this. So one lead of the cathode resistor is hooked up to this terminal through this wire here, goes through the resistor, and then comes back and goes to ground. Same thing over on this side. We've got the heaters, we've got the two resistors that create this virtual center tap, and then this comes over here to one side of the resistor, goes through the resistor, comes up and goes to ground. Then this goes from here to ground, there to ground. Then on this side, again, this is our B+, goes through, each channel has its own dropping resistor and cap, and then this is the filtered final B plus that goes to this output transformer and to this output transformer. Now, I haven't put in the caps here because it'd be kind of hard to see what's going on, but there's going to be like one cap that's going to sit right here, and then there's going to be another cap right here. These are some nice big audio note cathode bypass caps that we use on our nicer amplifiers. And then that does the filtering of the AC, or not the filtering, it shorts the AC on the cathode to ground. So that's what our cathode bypass caps are doing. And they sit right there. So we got those two guys, and then we're also going to be running the plate from here to there, and then from here to there. And one of the things I'm going to show you in a second is I do use the 3D real estate, as in the vertical distance here. And you can't see it looking down 2D. And like, had a comment about, I don't know why you're running the AC for the power switch near all this other stuff. Well, you'll see in a minute, it's nowhere near it. And again, when you have a 2 or 3 inch deep chassis, make use of the three-dimensional space that you have. So anyway, back to what we've got going on here. So again, these are ground points. So we have ground hooked up here. This is our grid leak resistor on the grid of the output tube. And we're using the only carbon film resistor in the amp, and I've found that carbon film resistors do sound good as a grid leak. It kind of takes the edge off of the, I would say, the detail and kind of the possible over brightness that metal film resistors can have. And for some reason, that grid leak position really has an impact on the sound. And so we're using a carbon film here. Then we've got a metal film 100 ohm grid stopper. The resistor's close to the pin here on the grid, and I haven't cut that lead off there. It looks like there's a wire coming off of that. And here we go. So that's our grid stopper. Here's our grid stopper. The coupling cap is going to hook up. The coupling cap's going to hook up here on both these channels over here for the input tubes. We're going to wire these up last, and we're really ready to power the amp up and see if these output tubes are going to bias up, check out the heater voltages and all that stuff. I already checked the heater voltage, and we have 5 volts even unloaded, so that's a good thing. Over here on this side, we've got the 7 volts coming from the transformer over to this rectifier, and 7 volts here. So let me see if I can turn the amp around so you can see how I'm using the three-dimensional space inside the amp to keep things like the AC away from the DC signal stuff. So as you can see here, here's this AC that comes over to the power switch, and you can see we've got this gap here between this and the DC. Same thing with the high voltage AC. We've got it spaced up a couple of inches away from this DC parts down in here. You can see how these are arched up so they stay away from everything. And then this B plus comes around. This is the filtered B plus, comes around, and this is up in the air and comes around like this. The other thing to note is, like, this is AC, this is DC. See how they cross each other at 90 degrees? Not only are they almost 2 inches apart, they're crossing at 90 degrees. And the same thing with like this wire and these wires. And so there's definitely a thought process to laying this stuff out. And this isn't just kind of willy-nilly thrown in here. I'm definitely, and again, like here's AC heater is going up to the front, and see how it's crossing at 90 degrees, and it's a couple of inches away. So there's no fear of getting, contamination between the AC and the DC voltages causing any kind of hum or noise in the amp. And like, these are DC, that's DC, so that's not an issue either. So anyway, I just wanted to kind of show you that so you understand how important it is to try to cross things at 90 degrees and use the three-dimensional space inside the amplifier. And one of the suggestions a viewer had was, instead of doing this switch like this, to put the switch on the front, which the owner didn't want, but then have another transformer in the back with a relay with low voltage AC coming up to a switch. And having another transformer inside the amp is just going to generate more electromagnetic noise. It's going to have to run all the time, so that's going to be hot. You can have a relay that could possibly fail. And in my opinion, a simpler solution is just to use the three-dimensional space inside the amp, and then if you do have to cross DC, make sure you do it at 90 degrees so that only just that much of the length of the wire is even anywhere close to this AC. And then with these being twisted, that helps cancel the electromagnetic interference as well. So I just want to kind of show you that. So yeah, I think we're ready to put the output tubes in, the rectifier tube in, power this thing up, and check our main B+. Check to make sure that our cathode voltage is good. Again, I got to hook up the plate of the tube to the output transformer and put these caps in. And I think we've got the output tube section all wired up. And so I'm going to flip the amp over and show you the top side and why I put some of the stuff in the places that I did. So this is a view from the top side. So here's our cathode resistors. You can see we got little grommets here. We actually drilled and threaded these holes so that these are just screwed down and they don't need nuts underneath them. And that turned out really nice. I like mounting them on the top like this so that the heat from those resistors can dissipate into the open air and they're not trapped underneath the chassis where it can cook the capacitors. I put some liquid electrical tape over these connections here so they're not exposed, and I think that just looks really nice as well as being functional. So one of the things that I struggled with was where to put the power switch, and the owner did not want the power switch on the front of the amplifier. And so I thought about putting it somewhere here in the back, but there's a hot tube right here, there's a hot tube right here, and having to like either reach over or trying to get like in this little gap here to reach that switch did not seem like a really good idea. So where I put it is just right here, and you can see you can reach in and turn the amp on and off, and then there's going to be a switch right here that the bias meter is set up so you can check one tube and then the other. But maybe not a super ideal location, but I think it's a fine place to put the power switch. And again, I had tubes in the amp and was able to, reach through here and turn this on and off. As long as you keep your hand kind of over here, you can turn it on and off without getting close to the tubes where you might burn your hand. And then right here is going to be a small volume knob that makes this integrated so it doesn't need a preamp. You can just hook a DAC or a CD DAC or a turntable preamp or whatever you want up to this thing, and you can control the volume right here. Again, I think that's far enough away from these tubes where you're not going to worry about burning your fingers. So it keeps the whole front of the amp clean, which is what he wanted, and that's the layout decisions we made on this amp. So anyway, let me go finish up some of this wiring and power this thing up and see where we're at. So again, thanks to all you folks that subscribe to the channel, Patreon supporters, people that are members of the channel, people who made donations when they find the videos helpful to the projects that they're working on, people that have bought my gear, that sort of thing, and help to support the channel. I appreciate all you guys, and again, just for watching the video. Thanks again, and until the next one, have a nice day.